So welcome, everyone, to the IoT Building Blocks presentation. I am Rudy Chetty. I am an AWS Solutions Architect specializing in IoT. And I've got my fine colleague here, Eric Martinez, who's the CEO and founder of Module. Now, IoT in general, the concept that AWS likes to bring to the table is that we split it into three regions. It is things, and these can be devices that have low memory, low CPU, even your cell phone counts as a thing. And they only really become useful is when they send that sensor data to the cloud. And this is where looks like we might have overriding frequencies going on here. So that's where the notion of pushing the data to the cloud comes in. And we take advantage of the storage and compute options. So all the devices that have low memory and low CPU can send their data up, and then we can perform useful intelligence on it. You know, this could be insights, it could be analytics. It depends on your use case. Now, if we go further and we break this out, you can see that this is where we expand the architecture to explain all the different service offerings we have. In this case, on the left, we've got the things. They sense and act. So they have sensors, and they can act on sensor data. And they are connecting securely to the AWS IoT ecosystem. So let's kind of go through that a bit more. So you can see that we can also expand it further to have secure local actions. We can have endpoints that go through those gateways, as we call them. And then once they get to the cloud, they can do the secure device where they're actually connecting. You get fleet onboarding, which is a case where you have multiple devices that need to be onboarded at the same time. And you've got audit protection. So you want to make sure that your devices are secure all the time. The last part that we bring up is the analytics portion. And we're going to dive into each one of these as we go along the presentation. So the first part, how do we securely connect to the actual AWS IoT ecosystem? Well, this is where the AWS IoT core comes in. This is the service that is the initial entry point into your IoT ecosystem. And these are the various features that it has: identity service, message broker, and so forth. Now, for the initial part, the identity service, this is where you want to get all those devices, no matter where they're sitting in the field, to actually connect. And you do that with various options. The first one listed here is certificates, specifically X509 certificates. Those are how you secure your devices when they connect to the cloud. You can do SIG-v4, signature version 4, for those of you who don't know, or even custom authentication tokens via a custom authorizer. Now, the nice thing is that at AWS, we give you options. You can do it yourself, bring your own certificate, or you can have AWS provision them for you. So it's that nice flexibility that we want to offer our customers because we don't want to have them locked in. Now, the process can be manual. So that means where you go to the device and you actually deploy the certificate or the key directly. So you install it on the device. Now, it could be semi-manual because, what if you're a manufacturing company and you want to actually get your devices out in the field, but you don't want to have to go, OK, my customer has to install the certificate. We could do a semi-manual approach where you put the certificate on the device, and before you actually send that on your truck to be delivered to the customer, you have an asynchronous process that actually registers the certificate. More so is that we have JITR, or just-in-time registration. That's where we actually say, when the device connects, that's when it's going to register. And that's a best practice from what we've seen in the field, and we recommend to our customers, because then you're not forced to actually go and manually provision all these certificates all the time. And we go one further. Once you're connected to the cloud, what can you do with these devices? That's where the IAM and AWS IoT policies come in. IAM standing for Identity and Access Management. That is the process we have in place so that when you're connected or logged into the AWS console, you have access to AWS resources. Now, if you push that to IoT policies, it goes towards your device, where you have a role. On the role, you put a policy, and that's linked to your device. So say your device connects, and you want it to connect to S3. Give it that policy. Make sure you adhere to the least privilege model, where you only give it privileges that it needs. So don't give it a star privilege or an asterisk. That would be counterproductive, I'd say. The other two options that you have is Amazon Kognito. This is a service that we provide where you can actually have devices utilize Kognito roles. I apologize, it looks like some of these slides with this clicker is going a bit odd. Amazon Kognito, you can connect via mobile, desktop apps, and it allows you to even federate those users. So if you have an existing Active Directory or LDAP, you can connect using those same users. It's a nice way of saying, hey, we want you to connect, but we don't have to reinvent the wheel if you already have an identity process in place. Now, if we go along, once the device is connected, what does it do? Well, it goes through what we call the device gateway. This allows long-lived bi-directional communication. So you can connect to the device, and the device can connect to you, and you being the IoT cloud in this sense. It is over MQTT, which stands for Message Queue Transport Telemetry, and the specific version is 3.1. Just a few caveats there is that we don't support all the functionality of that particular protocol. So if you're unsure, go to our documentation and just double check. We also allow WebSockets and HTTP. This is various options of connecting. We've also got the certificate management that I mentioned a bit earlier, the SIG-v4 X509. And the specific protocol we use is TLS 1.2. So if you try and connect over 1.1, which some devices do, alas, it won't work because we've gone to a more recent version of that protocol. Now, once you've connected, you've authenticated, you're sending messages, what's next? Well, we want to move that dial. We want to move the messages and broker them to a service, if not more than one service. In this case, this is where the message broker comes in. So, as you can see from the bullets, MQTT-based routing. This is the part where once the MQTT message comes in, you can say, well, maybe I want to store the data in S3, as I mentioned earlier. Maybe I want to call a Lambda function. This is where you would do it. And also, it works on the publish-subscribe model. I mean, for me, that's very amazing. Because you can publish once, but you can have multiple subscribers. So you don't have to create topics for each person. And I know this slide deck, again, is going a bit funny. The other two bullet points here is pertaining to the pub-sub in the sense that QoS 0 and 1 is what we call quality of service. And this actually pertains to the MQTT version we have, where we don't support QoS above 1. 0.1 being, a message will be delivered at least once versus once. And the way we mitigate that is with the next thing we're going to go into, device shadows. The reason I bring up topics is that we have reserved topics. We have reserved topics. Now you can see they usually start with that prefix, AWS, and you have wildcards. So you could actually, and this is where the hash comes in. It's either a hash or a plus sign. Now, it depends on how you want to use the wildcard, but think of it in this situation. You have a factory, floor 2 has all these temperature sensors, and you want to monitor all of them at once. This is where you would do that. So you wouldn't have to subscribe to each sensor's topic. You could do a bulk subscription. So it's a very powerful way of getting meaningful data using one entry point versus multiple. Now, if we go to the rules engine, this is once we've actually got the message, it's coming in, and we say, you know what? We want to route it accordingly. And the nice thing with the rules engine is that you have a rule that you use query language. Well, what query language would you think? SQL-esque. So you could do, in this case, select star from topic structure, where temperature is greater than 35. That's probably 35 Celsius. But the language is what most people are familiar with. They've used it before. It's something that is, I'd say, a more established standard that developers can get going as quickly as possible versus scrounging around having to learn a new syntax. And again, you do this on topics. Maybe you only want to do it when a topic succeeds. That's where you use the reserved topic, which is device/accepted. If you want to do it on the fail, you could do that as well. If something succeeds, do X. If it fails, do Y. Very flexible way of saying, let's move these messages as they come in. And how we do that? Well, it's the next part here. It was actions. And as you can see on the far right, those are some of the services that you can already plug into. Kinesis, EMR, S3, Lambda. It's all the services that if you've used AWS, you're used to actually using these services to their full potential. But with IoT, you can leverage them through the rules engine. I put two other points here. Republish. So if a message comes in, you can modify it and then republish it to another topic. Maybe the sensor data comes in Celsius, as I mentioned, and you want to convert it to Fahrenheit before it gets funneled up. You can do that. And ML is the piece that, as you know, is a big push for machine learning. You can also do that with this ecosystem. So again, very flexible, very powerful way of using the data that's coming in a meaningful way. Now, as I mentioned a bit earlier with the quality of service and 0 and 1, to mitigate that, we have something called a device shadow. Now, what is a device shadow? Well, think about it like this. Device shadow, well, it seems like the presenter likes going ahead of me. It's a representation of state, but it's a logical representation. It's JSON-based. As you can see that we've got something called desired and reported. We've got a latitude, longitude, a few other arguments here. But the nice thing is that with the reported and desired state that's bidirectional. So what that means is your device is reporting a state. It'll be in the reported portion. If you actually want to instruct the device to have a specific state, that's where you do desired. So you can get deltas where the reported and desired are not the same, like in this case here. And you can actually go in and say, well, look, I know the latitude is 3810 and longitude is 98.17, but I actually want to override it and say we're right here in San Francisco. So that's where you'd go and you'd set the desired state. And that happens through application interaction. Whether you're doing it on the console with an application, well, actually as a user, you're doing it via the API. It's all these ways that we allow you to interact with your devices from the desired and reported state. Now, to give you a nice example, because it's always good to see an example. We have this device on the left here. Looks like a fan, but for some odd reason, it has an LED that is blue. So as it goes to the device shadow, it's reporting that its state is blue. So if your application queries it, it goes, well, what's the color? It's blue. Now, if we go the other way and we say, well, look, I know it's blue, but on point number 3, I want to set it to red. But let's see what happens. Uh-oh, device wasn't connected initially, so it didn't report that state. But once it connects again, the device at step number 5 will say, I am reporting red, and it reports it back to the device shadow. So that's the way where you go, okay, now I know my desired state has succeeded by actually going from the application through the device shadow onto the device, and then the device itself is reporting what's happened. That's one of the nice, I think, features that the AWS IoT ecosystem offers. Another one is the registry. And again, we're touching on what we call the IoT core, AWS IoT core. So the registry, like it says there, just think of it as static data or metadata. So if you're onboarding lots of devices, maybe you want to take their serial numbers. Maybe if it's cell phones, IMEI numbers. It's all that data that you're collecting. And again, you can search through. The thing types that we mentioned is similar to the factory I told you. Say we had floor 3, now floor 5 is full of light bulbs. Let's group all those light bulbs as light bulbs under a thing type. So then we know that if we set light bulb to, in the previous slide, if we set it to red, all those light bulbs will change at once. Similarly, we can do groups. So we can group all devices on floor 5 as being on floor 5. Sure, devices can belong to multiple groups, but it allows you to interact with these devices with one click or one API call versus multiple. No more for loops going through all your devices. This is the way you do it. And that goes into what we call jobs. So again, say you have a group of devices, and you want to perform one common action against them. Set it up as a job. Run it against the group. Why would you want to do it against every individual one? That's not, it's not the way you want to actually go through. But that's where the registry comes in, and it's very, very powerful from a searching perspective, because you can find devices very quickly if you put them into the right groups, thing types, and again, you can create them as you see fit. So that summarizes what we call the, it's the click, there we go. The way you can connect devices securely. So once they come in, they're coming into the AWS IoT core, which drives the majority of our platform. But what if some of those devices don't have connectivity? What if they're actually sitting there going, well, I don't have a constant internet connection because I'm sitting in the middle of nowhere. But if you had something that could help me with that, and this is where the gateway, or what we call AWS Greengrass, comes in. So Greengrass is fantastic in the sense that it can help your devices connect to the cloud and be that local gateway. So if you had device A and device B, without Greengrass, they were communicating via the cloud with each other. The cloud goes, the connection goes down. Maybe you're in an area that only has 2G. This is where you put Greengrass in between, and you say, you know what? I want to be able to send messages between the two devices without the cloud. So this is where we leverage Greengrass, and we bring that AWS IoT flexibility and functionality to the edge location you're at. So we do that with local messages and triggers. So as I said, you can send the messages between devices. Local actions, so you can perform Lambda functions. Again, this is something that people have utilized in the past to actually take advantage of the serverless paradigm, where they write a Lambda function, and in this case, you can run it on your Greengrass device. The data and state sync, that's where the device data or its device shadow can actually be linked locally or synced locally, and say at the end of the day, you can send the device the latest state. So you could report the temperature to the Greengrass device throughout the day, and at the end of the day, then you're like, you know what, now I want to sync to the cloud. So it'll send that message up. We go into the next hexagon is security. It's the same security protocols you're used to, the same kind of functionality where everything from AWS side is, security is #1 priority. We want to make sure that these devices are secure. The local resource action, that's where you can actually access anything that's connected to that Greengrass device. So whether it's a fan, so if it's too hot, you can initiate turning on the fan. It's one thing. You can do machine learning inferences, so you can train your models using SageMaker, which is one of our other services. And then you can run those models via machine learning inference, we call it, on your Greengrass device. So again, you can monitor your devices in the field. The protocol adapters pertains to things like OPC UA. If anyone's used PLC, these are very, very skewed towards industrial. And those adapters exist. And over-the-air updates, so if you need to update the core, you can do this over the air. So you can send the updates streaming over MQTT. And what's nice is that it has failover. So if that device update fails, it'll roll back. We want to build in all this redundancy so that you actually get the flexibility and functionality you need without having to reinvent the wheel, as I mentioned earlier. So Greengrass, this is where it fits in. You can see that the Greengrass, there you go, the gateway. And if we go one step back, we go to the endpoints. Now, most people bring their own devices to the field, and they say, well, I want a way to connect, but I don't want to be able to, I don't want to have to, again, create my own stack. So this is where Amazon FreeRTOS comes in. Now, this is a microcontroller OS. It's based on FreeRTOS. It stands for Free Real-Time Operating System. And what's nice is that it comes with all the libraries you need to connect. You can connect to AWS Greengrass, IoT Core, with the built-in libraries. All you have to do is put in the certificates that you've provisioned. It's very, very flexible. I can tell you, even from using it, from building a device on a breadboard to using one that runs FreeRTOS, it was a lot quicker to get connected to the core than actually do it myself. So this OS is very powerful. And again, we've got over-the-air updates. code signing. It's the kind of functionality that you need built in. Just take advantage of it. And if you're wondering, go to our IoT console. You click on the bottom left, you get software, and then you can see all the devices that we support for Amazon Free RTOS right now. And you can buy those devices, get going. So that's where this endpoints, I'd say part of the slide comes in, is that we have Amazon Free RTOS. So we're going from the cloud to the edge, and then even further, like the edge of the edge, like I was going to the edge of the stage. Fleet onboarding, it's one of the other nice services we have. This is something, well, it's called Aws Iot Device Management, and it allows you to batch provision. So if you have multiple devices, and I'm talking thousands, where you want to provision them, you set up, it's a JSON template, and then you can run it against those devices. And what's nice is that it, again, allows you to search on it through real-time, it says the fleet index and search, where you're actually searching on that registry in addition with the shadow data. So you can actually search all that metadata or data that you have from both sides, and it's very, very flexible in the sense that you want to find devices quickly. The fine-grained logging is you can go to a device itself and define the logging policy. So if you want to say, well, look, this device looks like something's going on, let me increase it to debug, go in and see, oh, okay, that's what's going on. And you can do that on a per device, per group, that level. Again, over-the-air updates. As with most of these services, you'll see OTA come up because we want to give you that functionality where your customers don't have to send the devices to you to get updated before you send it back. You can just have them in the field and actually update them while they're live. So that's where this particular part comes in. The fleet audit and protection is a service we have called Device Defender. I like how it's coming in 2018, or we're in 2018. But again, it's a way to secure your devices. So you can set up audit device configurations, and those configurations can run against certain devices and see whether, this device looks like something's going on, let's take it offline, or let's change the certificate because the certificate is too old. Those are some of the audit configs you can set up. And you monitor your devices, all of them, so that if there is an anomaly, like I mentioned, a certificate that's out of date, rotate the certificate. Maybe 10 devices are using the same certificate. That's not a best practice, but this will expose it. And then you can generate the alerts, also put it into CloudWatch, and then mitigate. So whatever's going on, you can perform a relevant action. And again, with the patching security vulnerabilities, also like OTA, maybe a device's firmware is out of date. This is stuff where it does happen. Maybe a device got shipped out of the factory with the wrong firmware. This is the service that you'd use to take advantage of fixing that particular use case. Now, one of the final things I'll touch on before I hand off to Eric is what we call the analytics platform. Now, again, aptly named IoT Analytics. Now, what happens is you have various channels that you can set up, whether it's S3, whether it's Aws IoT, which is why it was designed, Kinesis. You funnel those in to what we call pipelines. Now, on those pipelines, you can enrich or filter data. So again, I mentioned the temperature example. If you want to convert between Fahrenheit and Celsius, this is where you could do it. And it's that pre-processing that you get to do before you send it on further. So through that pipeline, you're going to store it in what we call a data store. And this is raw data. So you're never losing the data before it got enriched as well. You then construct what we call data sets. And again, you can query using SQL-esque language. Even better on the last one is you can use Jupyter notebooks. So if you're used to using that way of doing data science, we offer you that flexibility. And again, plugging in with SageMaker, train your models, use those same models with the Jupyter notebooks in this case. Because a lot of people have started down that path, and we don't want them to have to change again. So they can use SQL, or in this case, Spark, if you want to use a Jupyter notebook. So that's where the analytics portion is. So if we look at it, this is our overarching architecture of the AWS IoT platform. But there's one more thing. It's the AWS IoT One-Click. So to get started even quicker, we offer these kind of buttons as an enterprise program. One is via Wi-Fi, and the other one is cellular. And these buttons allow you to actually define Lambda functions. And then when you click it, it'll call that Lambda function. So it's a simple case of configure and actually deploy. I mean, for those of you who may have used even our AWS IoT buttons in the past, this is slightly different in the sense that this one comes with a predefined certificate, which you can't change. But it allows you to put these in the field without having to provision those certificates. You just activate, set up the Lambda function, if that's what you want to do. And through the Lambda functions, you can actually have access or get access to any other AWS service. Because as you know, Lambda itself is a serverless function, and you can call different parts of the AWS ecosystem. And I know it mentions extract reports, so if you had X amount of devices in a specific place, you can run reports on it and say, okay, who's been clicking what, who's been clicking it once, twice, to see what's going on. I'll tell you with the one-click, previously the AWS IoT buttons, you could do 3 different clicks. You do a single click, you do a double click, or long click. The way I try and make people remember that there's 3 different clicks, I'll say, well, you're sitting at the office, 4:50 p.m., you're thinking, well, let me tell I'm going to say wife. I'll say, let's tell the wife I'm on my way home. So you push the button, sends her a text, say, you know what, I'm on my way home. Maybe you're thinking, I want to go out with the guys and have a drink. Double click it, go and have a drink. If you hold it for that 3rd click, you're telling her you're not coming home. So that's one way of helping you remember all the different offerings that we have. But as I go here, my time is up, and I will hand off to Eric Martinez, who's going to show us a cool demo. And just to note, when he walks up here, he's going to be wearing this belt. And I know this is recorded, so Mom, you said that I'm putting on too much weight. Eric told me the opposite. He said I'm not actually fat enough to wear the belt. So let's welcome Eric to the stage, and I'll switch over to the demo.
Thanks, Rudy, and I may have gained a lot of weight. So what I just wanted to do before I get up on the main stage is just really kind of just show you, when we talk about sensors all the time, what it actually looks like when you wearing sensors and what they look like on the screen. We have an accelerometers. There's always 3 accelerometers, the X, Y, and Z. Your force pressure newtons, these are just basically giving force. When I bend, you'll start seeing that right-hand side go up. Your magnetometer is your compass. So as you turn around in circles, you start seeing your sensors go crazy like that. And then finally, your gyroscope. And with gyroscopes, with the masters, it's the golf swing that really kind of just starts sending it out. It's your hip turn. And what you're trying to do is just figuring out how do you get all these sensors into something meaningful that means something. And everybody kind of understands the accelerometer is the core of the Fitbit device. But we got a lot more sophistication for our device. We're an enterprise wearable company that helps keep employees safe. And so not only do we use these sensors on our belt, we use a whole bunch of other sensors that show location, motion, and environment. So thanks, Rudy, for setting that. We can keep that.
Switch over.
Yeah, you can switch it over.
Cool.
So thanks. We built an activity tracker. And what that basically means is we manage the activities of craftsmen in the workplace. And so most notably, employees on a manufacturing floor, employees that are in warehousing situations, employees that are driving forklifts or doing driving for a living. They wear the belt that I'm wearing today. The belt is equipped with 8 sensors plus GPS. All of this is streamed every 1 second to the cloud. As you were seeing, that was real sensor data as I was moving. They were showing up real time to the cloud. It's showing up real time to the cloud, and then the employee can either look at it on a mobile app or on their supervisors on a web screen. We were on the IBM platform for a year and a half. We just converted over to the AWS platform. We'll talk about that a little bit more, but ultimately, we were able to get it for better, faster, and cheaper. And when you think about how quickly data can round trip, is really important when you're dealing with safety and safety type of measurements, so you can make those reactions and make those corrections. I was a former head of claims and operations for AIG. So we handled inside our book of business about 30,000 injuries per month for employees. I left about 2.5 years ago to start this company, thinking that there was a better way to prevent injuries in the workplace. The 8 sensors collect about 50 megabits of raw data a day. And what that does is, it's, like I said, it's their location, motion, and environment. We don't collect biometric information. And we convert that to actionable insights for supervisors, employees, to keep them safe. So part of what our wearable and what our AWS IoT Analytics can do, first of all, on our location, you can take a simple plot. This is a factory in South Carolina, and we can track an employee on the workforce on the floor today. And what we do there, when he does do an unsafe action like a bend or a twist and does it in a jerky motion, we can basically tell them exactly where that is in their assembly line in their process facility. The call-out box in orange you may not be able to see is just your simple temperature and humidity. We also convert that to heat index. As Rudy was talking about, there's certain things that you want to do right away. And getting the temperature and humidity, heat index is some simple calculations that you can get your system to take care of before it gets into a much more complex system. The screen that's darkened in the middle is motion. We do 6 activities that represent 37 metrics on the employee. And all that has to go back and get recalculated for the employee. So what we do is we tell them if they're walking, they're standing, sitting, driving, indoor driving on a forklift. And how we do that is the vibration. We calculate the vibration, and we can determine if somebody's sitting in a chair or on a forklift. And then twisting. And so we also do squatting, climbing on a ladder. All this is done through a 2 double-tier random forest model that we do in the cloud and brings back the applications, brings back the metrics for our employees and supervisors. Again, this is just a long, long list of all of the metrics that our system does. We have about a round trip time from when the data leaves our belt to it shows up on the scorecard in about 5 minutes. We believe that'll get down to 2 minutes and 1 minute as we continue to understand the computational power that we can take advantage of, as well as a lot of the memory that we can take advantage of. Battery is the biggest concern when you're designing a wearable or designing a sensor and IoT device. You're always doing a trade-off between your battery, your processing power, those are your and your radio. And those are the 3 big concerns that we kind of always try to manage is how much battery do we need, what's the radio, and then what's the processing power? How much calculations can we do on the edge versus what do we have to send out to the cloud? And that's kind of when we think about it. And what's good for us, at least in having a belt, is we have the ability to put all our battery power right here in the back of the belt. And so it gives us the ability to really upsize the battery strength so an employee doesn't have to charge it every night if they don't have to. In fact, if you don't use GPS, the belt can have a lasting life of about 5 days. Machine learning, we do a supervised machine learning model up in the cloud, and which returns back the activities and the metrics. We can bypass the cloud exactly. We have an SOS emergency button on the belt that we can press. It can bypass the the whole IoT infrastructure system and take a message from that and send the message right back to a supervisor, where then he can send a message back that says, I got the message, and the belt buzzes back. That's really good for lone worker situations. If you're working out there by yourself and something happens and you get injured, you can press the bell, the SOS button or the alert button, and wonder if they receive it. They also get a notification back that the message had been received and given back. And that's all, again, through the infrastructure that we built. And the rest of it, and we do have an SD card on the belt itself, so it does allow you to store data. And we do, so it doesn't have to, so if you don't have, you're out of range for Wi-Fi, out of range for how your radio works, we do store data on the belt, so no data is ever lost. And so that's kind of the core complex when you think about, when you're wearable or what you're doing for sensors, how are you going to track them, how much data they're going to create. GPS is your biggest hog of sensors. It does create about 15 to 20 megabits of data a day just to be able to show that breadcrumb report. So when you think about, data management and how much data sensors create, GPS, sensors are also not a very clean type of instrumentation, just because they get magnetic interference, they can get stuck. Sometimes they give a lot of faulty readings. And so we do rely on a lot of the services from AWS to clean our sensors up. And you just can't think that once you have a sensor reading, it's a good reading. You do have to do a little bit of analysis on that to understand. And so this is our infrastructure that we look at. We do a partner, Rtos is our partner that helps us build our infrastructure and maintain it and design it. Working from left to right, and I think this is everything that Rudy talked about, except for actually on the device itself. But working from left to right, we have the IoT ingestion engine. This is where our payloads come in from our sensors. Basically about 27 pipes, those 8 sensors create about 27 features, we call them, that it intakes into the system. It then goes into Kinesis and then the EMR cluster. Our EMR cluster is a primary, secondary type of a cluster, so that's the brains and the engine of our system, where it basically looks at all the work that has to get done and allocates that work across all its secondary processing powers. And then finally, as you work from left to right, it does produce reports, and those can either be done in Jupyter. We also use another reporting engine that we use on our mobile apps and our web apps to give it a better look and feel to show that. And so that's what we think about in our infrastructure system. It takes about 5 minutes for our data to round trip, it's I can tell you it's light years faster than where we were last year. And so that's probably for us one of the biggest benefits for us when we moved over from IBM to AWS, is that we got it faster. And that was really important to us because the data that we were handling was important data. And we wanted to really think about the computation time that it takes. The item that I dashed out in red is the area that we look at for IoT analytics. And that is more of the package platform that allows, instead of basically buying all these as individual pieces, your Kinesis and your EMR Spark clusters, is you get that in a package. And that's what we're looking at, where we're converting over to that instead of basically building out all these individual pieces as ones. This kind of gives you kind of a high-level view that we take our Kinesis streaming. Again, that's your layer. Your Kinesis is basically cleaning up your data. It's your time zones, it's your temperature, as you said, it's your stuck sensor data, it's all the stuff that doesn't necessarily jive with how your models are going to work. And then your models come in and just run on a big platform like that. Obviously, scalability is our key, and the ability to scale is another key feature for us as we looked at building out with AWS. The ability that we can scale up and down on this platform is significant. I guess the final point on this slide is that ultimately, we're a high RAM user, we're a high memory user, And we basically balance our infrastructure by how much RAM we need and how much we need for that short-term calculations. We're collecting sensor data every 0.1 seconds. We collect that's a motion set. We collect our location and temperature data every 1 second. And so that creates really a lot of memory that has to be done. And so when we optimize around memory in order to design and bring the metrics that we need. And I'm just going to quickly close. So we have times for questions for Rudy. We're moving over, we're getting out of the, so to speak, having to manage the primary and the secondary EMRs. We do run 3 in our backbone, as you remember in that first slide. We run it for basically our core computation. We run it for our couch, and we run it to ingestion. I think for us, the key piece was our computational time is faster. And so that was important to us when we were making our decision, how fast can we get our data round trip. The second key one is the cost-effective scaling. When you add capacity or take away capacity, versus just buying butts and seats license or butts and seats processing and you may not use it, that totally changes under the AWS model for us. And so we have been able to cut our operating costs probably by about 1/3 compared to where we were operating at before. And then the reporting and the visualization, you don't give up anything reporting and visualization. You can use your own tools, or you can use the Jupyter tool as they speak to, and provide the round trip capability. So Rudy, that's kind of my spot. And got to 10 minutes here.
We got about 10. So looks like we've already gone through the demo. So these are the fun slides that complete the session survey in the Summit mobile app. Wow, it even shows you how to complete it. Would you guys believe it runs on IoT? Actually, I have no idea if it runs on IoT. Look, let's open it up for questions. I think we've got time because it's about 12:42. So, already got one.
Yeah, so question for both of you. So, especially with your application with sensing every second and using an MQTT protocol and an industrial setup, what do you do about losing data? Like if you lose data, given that you have a 0-1 quality of service,
Yeah.
is it just acceptable in your application, or you have to do something to try to maintain memory on your device, or how you handle that the server may be down and to have this publish?
So just to repeat, the gentleman's asking about in the industrial setting, when you send an MQTT message, especially in the module case, how do you deal with if servers are down or there's no connection? So I'll let Eric give.
Right, and so it is important, but it's not critical, right? So if we lose a second of one data, we don't lose sleep over it, and it's something that we track. We basically track how much payloads we send and how much are received, and we go back and change it. It hasn't been a problem for us because, one, we have the data stored on the SD card we can always go back to, and then two, we basically been tracking it, and we haven't found that quality of service has impacted our ability to run our reports. And so I would have to say that the 0-1, we're probably at a 99.9% of the data that we get. And if we lose 4 or 5 seconds during the day, it's not a big deal for us.
Yeah, and just to add on to that, that's where the device shadow comes in. So you have that logic. For this application, you could, if you're going to stream, but yeah, for other use cases.
I think one of the problems is you guys talk about the shadow.
Yeah.
In applications where you need to track
So you,
reliability.
yeah.
Yeah, so we wait till so on our firmware itself, we look for the Wi-Fi signal strength or the radio signal strength, and we verify the signal strength before we send as well. So if the signal strength is not greater than X, we hold the data till we get a strong signal strength. This is the other way we get around that one too, just to ensure that we're not losing data in transport.
Okay, I see that gentleman, and I'll come back to you. Yeah.
So how scalable is that? So we think, we're probably in the thousands and, 2,000 to 5,000, probably around 5,000 devices that will be running on that. Yeah.
Cool. So I think we had this gentleman as well.
RTOS that you mentioned, so I guess like it runs on the edge IoT devices, right? So how much space does it require and what primary features does it support?
So the gentleman asked about free RTOS, how much space does it require and what features. So with the space, it's going to vary between the device you're actually installing it on, because those devices, it's essentially tailored for that, where it's got the libraries that it's just needed. To give you an example, something like the STM32 from ST Microelectronics, that device has built-in sensors, and all that code is taken out for the free RTOS or Amazon free RTOS version so that it's more lightweight. If you need to add them back in, sure, but it gives you all the functionality to connect to the IoT core or Greengrass. So all of that's baked in, where once you've provisioned the certificate or your thing certificate, you actually put that on the device, and then you can connect as quickly as that. Yeah? I think we had that gentleman. I'll come to you. Yeah?
So how would you use Greengrass in this kind of a wearable scenario?
You want me to answer?
Yeah.
Okay, so the gentleman asked how you would use Greengrass in this kind of scenario. So Greengrass right now supports up to 200 devices connecting to it. This is always increasing. In this scenario, say you're in a factory floor, and again, as Eric mentioned, the device's signal to the Wi-Fi or RF is not as good as it should be. You can actually say, well, let's have all those belts reporting to Greengrass, and Greengrass is actually the one that's connecting to the IoT core. So all those messages are still being stored locally, similar to what you're doing now. But Greengrass would be that intermediate step to get to there. If the devices cannot access, let's say, good Wi-Fi signal, route them through Greengrass. Yeah. I think that gentleman, and then we'll come to you.
Are you saving the dirty data, or are you saving data after collecting the data in SD?
Yeah, both. So we do keep a core record of the data, and then we store it again. So ultimately, at 55 megabits turns into a little bit over 120 after enrichments and data savings that we do.
Yeah, that just gentleman asked if, if you're storing the raw data and the process data.
We basically ship the raw data right off the Glacier as soon as we're done, as soon as we get it, just as a course of record. And then we then work the S3 and Couch DB for that.
Jim?
Greengrass has a 200 device limit. If you have more than that, do you daisy chain them, or you just have multiple and just have the devices
So the gentleman asked if we have more than 200 devices, how do we manage that with the Greengrass core? So yes, you deploy multiple cores, and different cores will host, different devices will go towards it, yes. And then you keep going. To give you an idea, even early last year, it was 100, the limit. So as with all the things that we release as AWS, the more and more customers use it, the more use cases they come up with, and they say, well, 100 is too low. Let's do 200. So again, as limits increase, we pass.
So are the Greengrass aware of devices? So meaning, are they chain or just you have 200,
Yeah.
registered to Greengrass 1, another 200 registered to Greengrass 2?
So you'd have devices registered to separate cores, yes. Yeah. Sorry, and I think we saw, was there one or two more? Oh, it was this gentleman here. Oh.
Does the belt talk to the greenhouse in case there's no Wi-Fi through RF?
So I think that's, well, you're not using Greengrass right
We
now.
don't
Yeah,
use
so the gentleman asked if it talks to Greengrass right now. Not in their present architecture, but it could be if you wanted. It's just the case that right now they're going directly via Wi-Fi or RF. Is that correct? Yeah. I beg your pardon?
In case if you want to talk to Greengrass, what's the means of communication? Is it Bluetooth or is it wireless?
Oh, I see what you mean. So Wi-Fi, yeah, if you want to. I guess.
Well, just curious to see more about the belt.
Yeah.
I'm just curious to see what does it weigh, and is it custom built per customer, or you want to build with specific?
Yeah, so No, so the core setup is 8 sensors and the GPS, but some customers want some environmental sensors for air quality and noise protection. So we do have an integrated circuit board we can pull out that add whatever sensors they want for their persona. And so it weighs like 10 ounces. It doesn't have any, it weighs just like a normal heavy leather belt. There's no weight to it. The batteries are actually located in the back of the belt.
Cool. Oh, this gentleman here.
Basic question, what's the distinction between IoT Gateway and IoT Greengrass? They're both local, right?
You're talking about device gateway versus Greengrass. Yeah? So device gateway being the gateway on the cloud, Greengrass being your edge gateway. Yeah. Yeah. So the gentleman asked the difference between the device gateway and Greengrass. As I mentioned, the IoT Core's device gateway is sitting on the cloud versus Greengrass, which is a local edge computing gateway. Yeah. Well, looks like.
All right, we cleared
Okay.
it out early.
Well, thanks a lot. Well, thank you, everyone.
Thank you.
Thanks for staying.